So let's imagine that we're building an e-commerce website for clothing. This is a website, an online store where you can browse shoes, shirts, dresses, tank tops, jeans, etc., etc. And you can find whatever you want and buy it. We're going to call our brand Dome Train Clothing. And in Dome Train Clothing, for starters, we have only the following six clothing items. We have shoes, polo shirts, dresses, jeans, shorts, and tank tops. Now, if these are the clothing items that we have, then we'll need behind the scenes in our system, in our application, we'll need to represent them in some way. Let's imagine that this is how it's represented. Now, everything here is records just to save on some space, but I want you to imagine that we need some type in the end to store the underlying data. Now, because each clothing item is different, then the properties and the attributes that they will have will be different. For example, the shoe will have in it the shoe brand, the size, the color, whether or not these are sports shoes or not, the material of the shoe, etc. But for jeans, then we'll have other things, like, for example, the waist size, whether the fit is regular or slim, etc. Each one of the clothing items has different properties, which explains why we may want to create a class per clothing item instead of having one class containing all the various possible properties that may not be relevant for some of the clothing items. So let's imagine that these are the classes that hold the underlying data, plus some behavior. For example, in the shoe, we may have specific methods for the shoe, likewise for the jeans, etc. Each one of them, these are our domain models. So all of this is in one layer or one component in our application, but in another part of our application, we want to display the items to the user. Now, let's imagine that in our system, there are three ways of displaying the underlying items to the users. There's either a compact view where we have an image of the item and some title. We have the detailed where we have the image, the title, but also some description of the product. And we also have a mini where we have the image and overlaid we have the title of that item. Now, I'm sure you can imagine a real world scenario in which we have different views depending on the page you're at, depending on the device you're using, on the OS. There are various representations of each one of the items. Now, I want you to really imagine and invest the brain power into thinking, how would you actually model this in code? So we have, for example, the compact view. How will you represent a shoe being displayed in a compact view? We need to somehow, based on the shoe type that has its specific properties, to compose the image and the title. Now, for the shoe, the image may be computed as something like the brand underscore and then let's say the color, etc., etc. And this is how we represent the image. But for a different clothing item, this computation may be different. Likewise, for the title. Perhaps if it's an athletic shoe, then we say this is a sporty, blah, 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 some title. But for pants, this computation will be different. It makes sense that if somewhere in our system, then we have the shoe, it makes sense that we'll want to keep our shoe domain model simply a shoe without involving in it whether we're using a compact view, a detailed view, or a mini view. Now, currently we have three, but I'm sure you can imagine where we may have 100 different views. Sometimes you want to see the page for the shoe, sometimes you want to see just specific attributes for the shoe, and each one of the views will require a specific manipulation on the shoe properties to obtain that data. And this is true for each one of the clothing items. So the naive way to solve this is doing something like the following. And we'll break this down step by step, so don't be intimidated by the amount of code that was just displayed on the screen. So we have, for example, the detailed shoe view. This is a class that simply extends some clothing view class that has the method display. So in the end, each one of the views has a display method, which you can imagine draws it to the screen or returns some HTML or does some action where in the end we display the content to the user, or we satisfy our need to display it to the user. So in the naive approach, and this is something that you may actually end up doing if you're building such a system, is you create a detailed shoe view, and in here you'll go ahead and obtain the data that you want by manipulating the properties of the shoe. Over here, what we're doing is we're creating the image URL by taking the brand and the color of the shoe. We're taking the title by doing some manipulation on the brand and the size. And the description is something that has to do with both the color, the aesthetic, and what the material is. Finally, the way we display it will be different for each one of the views. So over here, we're saying detailed view, but you can imagine that constructing the actual view, the card, whatever it is, will be different based on the view type. So this is for the detailed shoe view. For the compact shoe view, then we have something else. Likewise, for the mini shoe view, then we also have something else. Now, this may seem like a fine solution because it makes sense. We have these objects that represent the different views that we have. But if we think about how this scales, then we end up with 3 classes per clothing item. So for the shoe, we looked at the 3 options, but we'll need the same for jeans and likewise for every other clothing item. This, of course, doesn't scale well. What happens when we need to add a new view type? Now we want a view that can display something a bit differently. We need to add a view per clothing item. If we add a new item, then we'll need to create a class per view type. And I'm sure you can see how when we're building this e-commerce website, then currently this is what we have. But in the future, we'll likely have many classes where each one of them will need to have various representations. And we're actually not talking only about the duplication of classes. That's one problem, but another problem is that if we change the logic of how we create the mini view, whatever change we do over here needs to happen for each and every one of the mini views. We don't have a centralized place where we have the logic of constructing the mini view, but it is duplicated for each one of the items. Hopefully, you don't need more convincing to understand why this solution, even though this is what you may naturally write when you're just starting the system, why this is something that doesn't scale well, is hard to maintain, and just not fun to work with. So now I want us to think together, perhaps there's some design pattern that we can use that will simplify the design of our e-commerce website. Oh, it just hit me. I think we can use the bridge design pattern. In the previous subsection, I had this epiphany that perhaps we can use the bridge design pattern. I want us to build the class diagram of what this may look like following the bridge design pattern and how this can solve the problem that we talked about before. So what we're going to have is the following. We'll have the abstraction be the clothing view. We'll have the refined abstraction be the various view types that we have. The view types are going to be detailed clothing view, and the other ones will be the compact clothing view, and finally, the mini clothing view. Now, each one of the clothing views will have what we're going to call a clothing formatter. So let's call this the clothing formatter, and let's give it the I prefix, indicating that this is an interface. Also, let's update the field over here to be the clothing formatter, and let's update the type to be the clothing formatter. Also, let's update the foo method over here to be the display method like we had in the previous subsection. For the clothing formatter, let's give it the following 3 methods. Let's give it the format image URL, which will return a URI, and this is how the clothing viewer, each one of the clothing views, will get hold of the image URI. Let's do the same thing for the title, and likewise for the description, which means each one of the concrete implementers now will be implementing the I clothing formatter, and we'll have a clothing formatter for each clothing item. So we'll have the shoe clothing formatter, which will know how to implement these 3 methods, but specifically for the shoe. Like we said, for the shoe, then we're manipulating the underlying resource in a specific way to create the URI, and likewise for the title and the description. This will change per clothing item, which means that now we can have in our system multiple clothing items where each clothing item can grow and morph independently, and all we need is some formatter that knows how to take that object and extract from it or format the details that we need. This, of course, needs to be shoe and not show, and we need one of these for each one of our clothing items. So I'll go ahead and create that. So overall, this over here is what we have. We have a class per view, which is our refined abstraction. We have a class per formatter, which is the concrete implementer, and we can combine these however we want to create all the various views that we need for the underlying products. Now, some of you have already noticed that this actually doesn't end there. So each one of the formatters also uses the actual object that it's formatting. So each one of the formatters, for example, the shoe clothing formatter, will have behind it the shoe itself, which has its own properties, etc., that it uses for formatting. Now, I want to take you back to the adapter design pattern because what we actually have here, if we just take the shoe clothing formatter and the shoe and we look at it independently from the rest of the class diagram, and next to it, we put the diagram of the adapter design pattern, then I want you to notice how what we have between these two objects is the adapter design pattern, more or less. So we have the client, and the client is the view. So the detail view, the compact view, and the mini view are the client. The client needs or knows how to work with the interface format image URL, format title, and format description. What the formatter does is it adapts the shoe, which is in one interface, to this interface that the client knows how to work with. So overall, what we have, if we look at it next to one another, we have the client being the view. The view in the display method needs to work with the interface, which is format image URL, format title, and format description. And the formatter is an adapter that takes the shoe, it uses it to adapt the shoe to the interface that the client knows how to work with. So if we look at the entire diagram from another lens, then what we actually have here is we have the bridge design pattern, where this is bridging between the views and the various formatters, or between the refined abstractions and the concrete implementers. And each one of the formatters is actually just an adapter for the underlying clothing item. So hopefully this is starting to make sense, and you can see why being familiar with these design patterns can really help talk in a shared language where I can just tell you, listen, this implements the adapter design pattern, and maybe before I even showed you anything, you already understood what I mean by the adapter design pattern and how the formatter implements this pattern. So I want you to start noticing when doing code review, when writing code, how sometimes you're just implementing actually a pattern. Or if you're looking at something and it doesn't really make sense, perhaps this is just following some pattern that you're not familiar with. And once you'll be familiar with it, you'll see that it actually isn't that complicated. So now that we have an example, we know what the class diagram looks like, let's do a quick section recap, and then let's start implementing this entire thing in code.